So just now we just solve the examples that the denominator comes with quadratic factors that can be factorized. So for now, we will look at when we have equations, the denominators with quadratic factors that cannot be factorized. Okay, you can't be factorized. So let's look at example here. You have 7x plus 10 over x minus 2 multiplied with x squared plus 7x plus 3. Okay, so the first thing that you need to do is to identify what is x minus 2. It is just linear factor. So linear factor, you can just rewrite them with the constant there. Okay. So now let's look at here. This is quadratic. Alright, quadratic. Quadratic factors. You have one you can factorize, another one you cannot factorize. So let's look at here. X squared plus 7x plus 3. Okay, can you factorize? Can you factor this one? Okay. Okay, if you try to solve it, you can't factor this one. So this one, it comes when you can't factor the quadratic factors. Okay, when it cannot be factorized, you just copy, okay, the quadratic equation there. Okay, but for the constant, it will not be single constant anymore. It will be like I can say as linear equation there. So like this one, bx plus c. Why it has to be bx plus c? Because you already use a there. Okay, you already use a there, so that's why you start with b, and another one is c. But it must be in form of linear. All right, so I can say that it is like linear actually. All right. Okay, but we have to use b and c. Okay, let's look at another example. You have 6x squared minus 3 over x and 5x squared minus 6x plus 2. Okay, what is x there? X is our linear factor. So just write x as your linear factor. Alright, so you use a because it is, you start with x. So you must use a there. Okay, and then you have 5x squared minus 6x plus 2. If you check, it cannot be factorized, so just copy it down there here. Okay, kita copy saja dekat sini. But on the top, it will not be constant anymore. It will be in form of linear. Alright. Okay, let's arrange the equation. Okay, class. Let's say I take the same question here. 7x plus 10 over, you put x squared plus 7x plus 3 bracket x minus 2. Okay, so cannot be factorized, right? So bila cannot be factorized, you just copy it down. Copy here, 7x plus 3. Okay, x minus 2 is just a constant, x minus 2. So on top, you will have ax plus b, and another one you will have c. Okay, so that's how actually you rewrite the numerator for denominator that cannot be factorized. So whatever that comes first, you will get the a. Whatever comes later, you will don't get a. Okay, can you see the difference between the example that I shown here? So let's go back on our equation. Okay, let's focus on the denominator. Our first denominator here, our first linear factor is x plus 1. Okay, x plus 1 here is our linear factor. Linear factor is our type 1. So for type 1, we don't have problem. Next, x squared plus 5x plus 1. It is our quadratic factor. So quadratic factor is type 3. Okay, for type 3, quadratic factor, we need to check, okay, either it can be factorized or not. So this is our quadratic factor. You can use your formula or you can use your calculator and you will end up with this value. So our conclusion is the quadratic factors cannot be factorized. So we will continue. Rewrite. Our first step is rewrite the equations. Okay, so x plus 1, x squared plus 5x plus 1. So separate them into x plus 1. Okay, another one is because you can't factor, so we just copy it, right? Okay, now I want you to focus on the constant. For x plus 1, we will have a, but for quadratic factor that cannot be factorized, it will be bx plus c. Okay, it will be linear there. Okay, so in the middle is our positive, okay, plus. Our next step is second is to equal the denominator and compare the numerator. Alright. So here is our next step. So let's write it quickly. So we will have for x plus 1. A here will multiply with what? You will multiply with x squared plus 5x plus 1, top and bottom. So you will have a x squared plus 5x plus 1 and bx plus c. Okay, must put the bracket because it's not single value. Bx plus c will multiply with x plus 5. So here we are, our equation inside the green box that we will use for us to find the value a and b. Okay, it will come to the same concept, the same step as before. Okay, next we go to step 3. Okay, for step 3, let's substitute value. Alright, do you have any factor that we can use? Yes, we have x plus 1. So that's mean we will substitute as x equal to negative 1. So let's substitute the value. Negative 1 plus 1. A. Do you have the factor here? X plus 1? No. So just substitute the value. Okay, you have negative 5 plus 1. And for B, okay, you have x plus 1 there. So just write as 0. Okay, you have x plus 1 here. Can you see this one? Because you have x plus 1 there, then you the calculation at the end will be 0. So no need for you to calculate it. So let's calculate. You have negative 3. A also negative 3 here. So A equal to 1. Okay. Because so do you have any value that you can substitute from the linear factor? No. Okay, so here let's use try and error. Okay, I will choose x equal to 0. So let's substitute. You get on the left hand side, you get 1. On the right hand side, A, because you, okay, for try and error, we will use what value we have before. Alright, we will use the value that we have before. So just substitute A as 1. Okay, here you will have 1. Am I right? Okay, and plus C. So C is equal to 0. Okay, next value, let's go to another value because you already used negative 1, 0. Let's use equal to 1. X equal to 1 on the left hand side, you will have 5. Use A is 1. Okay, and then what do we have? We have 7 here. We have B. C is 0, so automatic 0 there. Plus 0 means multiply with 2. Okay, so we have 5 equal to 7 plus 2b. So b is equal to negative 1. Okay, so here we have the value of A, we have the value of C, and we have the value of B. Okay, remember for try and error, we will use the value that we got before. Okay, you got 0 here, you got 1 here. Next, let's look at what should we do. This is our third step. Okay, let's go for our fourth step. To rewrite them in form of the equations. Okay, from the original equations, you have x plus 1, x squared plus 5x plus 1 is equal to, okay, sorry, let's make them padam. Okay, we go to our fourth step. Rewrite the original equations. Alright, and then write the denominator first, x plus 1, and you have x squared plus 5x plus 1. Okay. Okay, so we separate them. So let's look at x plus 1. X plus 1, our constant is A. Let's look at A value. So it is just 1. How about x squared plus 5x plus 1? It is bx plus c. Okay guys, bx plus c. Our c is 0. So bx is negative x. Okay, because it is negative x, you just... Okay guys, let's look at example 4. Express 3 over x plus 2 multiply with x squared plus 1 in partial fractions. Okay, as usual, we will start with identifying the denominator. So what is x plus 2? This is linear factor. Okay, so linear factor is type 1. Okay, how about number 2? X squared plus 1. So here is quadratic factor. For quadratic factor, we have to check whether you can factorize or not. So this is our question marks. Okay, let's look at back. What do we have? Because we check, okay, quadratic factors here, you can't be factorized. So that's mean we will use as the equation. Okay, just rewrite x plus 2 and x squared plus 1. For x plus 2, you don't have problems because it is just a constant a. But for x squared plus 1, remember for quadratic, at the numerator, it should be linear here. So because we already use a, so next use bx plus c. Our second step is for us to equal the denominator and then compare the numerator. So for us to equal the denominator, let's just quickly calculate the numerator. So for the numerator, you will have 3 equal to a will multiply with x squared plus 1. And bx plus c must come with a bracket, okay guys, and multiply with x plus 2. Okay, so next we will calculate our value by substituting the value, our third step. So linear factor that we have is x plus 2. So we will substitute x equal to negative 2 into the equation here. So we have 3 equal to a. Okay, before you substitute, let's look at a. Do you have the same linear factor? No. Okay, and then you substitute the value, you will have 5 inside. And for this one, you will have x plus 2 here. So automatically just put 0. So a is equal to 3 over 5. Okay, next we will continue with substitute value. Alright, because you already used the linear factors there, let's use try and error. Alright, let's try and error. X equal to 0. For x equal to 0, you will have on the left hand side, you will have 3 equal to a. We already use a we already find here, so use a value. Okay, for try and error, you will need the values before that we already found. So here we will have 1 plus c multiply 2. Okay, from here we know that we can get the value of c. So can you calculate this one? We will have I show the calculation. 3 equal to 3 over 5 plus 2c. So 2c is equal to 15 minus 3 over 5. Okay, for you to calculate, you just equal the denominator by multiplying, okay, this one by 5 over 5. Alright, so c you get equal to 6 over 5. Okay, so you get one value here, c. Next one, we will substitute with try and error another value. I will choose 1. Okay, so on the left hand side you will have 3. On the right hand side you will use a value here. Okay, so you will have 2 plus b plus 6 over 5, the c value that we found earlier, and multiply by 3. So at the end, you should able to get b equal to negative 3 over 5. Alright, so thus here we already got the a, c, and b value. Okay, so lastly, our fourth step is for us to rewrite the equations back. Okay, x plus 2, x squared plus 1 is equal to, let's rewrite the denominator first, x plus 2, x squared plus 1. Okay, what is our a? Our a is 3 over 5, so you will put 3 over 5 here, bracket. Okay, brackets means multiplication, that's why it is very important. Okay, how about this one? Bx plus c. Okay, our bx plus c should be here. Okay, let's say I put plus here. Bx is negative 3 over 5. X plus c is 6 over 5. Okay, how did you simplify for this one? Okay, as you can see, it's good because it has the same denominator there. So what you should do is actually just put 5 at the bottom. Okay, let's rewrite it. 3 over 5 x plus 2. So you will have 5x squared plus 1. Okay, if you have a negative here, okay, as you have a negative 3x plus 6, okay, the easiest way for us to rewrite is actually put the positive in front and negative at the back. So here you are. Alright, okay, or no, that's the best way for you to rewrite it. Choose the positive one to be in front and the negative at the back. So here you will maintain your positive there. Okay, so that's how you answer for this one. So as you can see at this question, you have type 1 and type 3 that cannot be factorized. So that's how we combine everything in the same equation for you to write down in the form of partial fraction. So this is your partial fractions. Okay, so it is not difficult, it's fine, and just do the calculation nicely. I think there will be students that will ask if you want still to put negative 3x in front. Okay, what happened if you put negative x in front, negative 3x in front? So you want to put here, you want to put negative 3x. Okay, let's look at the values of 6. 6 is positive 6. So if you put negative here, you have to put here as negative 6. Okay, because negative minus here means for every terms. Alright, so if you expand it back, so you will get negative x, and then negative multiplied with negative 6, you have plus 6. So it will have the same value as our original linear factors there. Okay, so it's good enough. Okay, very good. Okay, so we actually done with the contents for 6.3 partial fractions. Okay, class, so this is the exercises that for you to do. Okay, please do all these questions inside your books, and remember to do all the exercises in the tutorial books as well as the lecture books. Okay, so so it's almost done with our content. All right, let's look at back for 6.3. What do we have? Partial fractions. Okay, class, for partial fractions, it depends on your denominator. All right, your denominator will comes in forms of 1, it is linear factor, number 2, repeated linear factor, and number 3 is quadratic factor. Okay, for quadratic factors, it will have the quadratic factors that can be factorized and cannot be factorized. Okay, for this one, if it can be factorized, it may include part 1, part 2. Okay, it may be. Okay, but for cannot be factorized, it may also have part 1 or part 2 that comes along with the equation. Okay, sorry, for this one, quadratic factor that can be factorized, it will be the linear factor. So it will have 1 and 2 or 1 or 2. Okay, for this one, it the linear factors that already comes along with the equations. All right, so this actually what you did learn. Okay, for this part 6.3 partial fractions. Okay, so please do know what's the difference between linear factor, repeated linear factors. For quadratic factors, if you can be factorized, what form it can change at the sometimes the factors already comes along with the equations. Okay, for cannot be factorized, it can also have part 1 or part 2 if it already comes along with the equations. Okay, once more I want to highlight is for quadratic factor that can be factorized. All right, here when you change the quadratic factor, usually you will change it, you will turn it into either linear factors only or repeated linear factors, depend on the quadratic factors. You get what I mean? Okay, so that's all from me for lectures 4 and 5 for chapter 6 polynomials part partial fractions. Okay, don't forget to follow me on my YouTube to subscribe, like and share. Okay, thank you and good luck. Okay, so it is not difficult. Try to always do exercises for mathematics so you can master well for our mathematics course. All right, goodbye.